King Tut. Right.
Hello everybody, this is King Tut here, and welcome to your third electronics tutorial. In this tutorial, I'll teach you guys voltage and current. These two are really important, and without these two, you can't make circuits. So what is voltage? Voltage is more of a force that drives electricity forward or backward. So think of water analogy. You have to have some kind of a pressurized system or pressure to make the water flow, and that's what voltage acts as. So without voltage, there won't be any electricity. And there are voltage sources such as batteries and bench power supplies. And to measure voltage inside of a battery or power supplies, the unit for it is volts. So for example, let's say I have a battery that contains 9 volts in it. That's basically how you use the unit. You use V after the 9. And this is a symbol for voltage source. So this is a DC voltage source symbol. Usually it's this, or a circle with a plus and minus, or this one, which is an AC. So I'm going to discuss DC and AC later on in the series. And this is a battery. So what I mean by forward or backward, so there could be a positive voltage that drives electricity forward, and there could be a negative voltage that could pull the electricity back and make the electricity go the other way. These are examples of voltage source. Some use plugs, some voltage source do not use plugs. So let me go each one by one for examples. So this one is a charger, and it's not just any charger, it's a laptop charger. And I've been using it for my laptop to charge the battery, and without this, it wouldn't be, my laptop will not be recharged. Some batteries last about 5 hours, others last about 2, and others last about 12 hours. Depends on your laptop. And inside of here is a power supply that supplies the voltage to here. So you need to plug this in for this to work. So this one, I actually made this one. This is a lab bench power supply. It could be either constant or adjustable, but this one supplies voltage as well, and you could use it for circuits. If you want to experiment your circuit, this is a good tool to have. There are ones on Amazon or eBay or whatever your favorite online store website is. They sell those for like around $70. So if you don't feel like building your own power supply and wanted to get a power supply very quick without having the hassle of maintaining it, then go ahead. Go Google search power supplies, and hopefully you find one that is cheaper. So these are the batteries. So usually they don't last long, but their duration depends on different devices. If some devices have very bad circuit design, then none of these would last long. So this is a AAA battery. Let me get this in focus. This is a quadruple A. My bad. This is a quadruple A. So a AAA battery is a bit thicker and bigger than this, and a double A is thick and way bigger than this. And it's 1.5 volts it's supplying. This one is a 9 volt battery. it always supplies 9-volt battery. Always. And this is 3-volt coin cell battery. Let me see if I can get this in focus. Yeah, if you see it closely, you could see 3 volts. So these ones, there are smaller ones than this and are used in watches. There are other devices that makes use of this, but I never seen any device that makes use of this other than watches. So by saying flow of electricity, I meant current. So current is basically the flow of electricity. Voltage is what drives the current. And electricity flows like a river, but on wires. So wires has to be conductor, or else electricity cannot flow freely. And we follow the conventional current flow. So usually current goes from the positive terminal of the voltage source to the negative terminal of the voltage source. So without voltage, current cannot flow. And there are current source, yes. However, there are always going to be a constant voltage on it. Without voltage, there won't be any current source. Amp is the unit used to measure current, and it's symbolized by A. For example, 2.5 amps. That's a very high amp. It could be used in very high power supplies. If you got your finger on a very high voltage with 2.5 amps, you're just done. You're done. You would die. This is a symbol for current source. But usually when you're drawing arrows on the circuit, that symbolizes current flowing in the wire. So what happened if current and voltage were to be combined together? You get power. So power is basically when you combine voltage and current together. And that generates electricity, actually it generates power to let's say a resistor, say a light bulb. So that's basically how power works. And power, the equation for power is P equals P is for power, I is current, times V is voltage. Sometimes people put V times I. It doesn't matter because of commutative property. The result is going to be the same. And watts is the unit used to measure power. For example, 60 watts. Usually a light bulb, some light bulbs can withstand 60 watts of power. So it doesn't matter how much voltage, how much current you have, as long as these two combined together becomes 60 watts. Even though voltage and current are very important, these two alone won't help you build a circuit or light an LED light. If you just put an LED light on a voltage source, it's going to burn out because current rises to infinity. It has no control. It's unstable. So you need to have something that stabilizes the current. And I say stabilizes because I have no other way of saying trying to make the current constant. So there's a way to stabilize or make the current constant when you're lighting up an LED so that you don't burn out an LED. And that's going to be in the next tutorial, which is resistor.
Thank you so much for watching. If you really like my video, please give it a big thumbs up. If you're on YouTube, BitChute, or BitTube, please subscribe to my channel. If you're on Vlare, please follow my channel. If you're on Library, please follow my channel and download my video. And I hope to see you in the next tutorial. Bye!